choices. Please list your 4 choices and be sure to register by next Friday. I think that's right, next Friday. Okay, we have a wonderful program today, and here's Lise Matthews to tell you all about it. Lise?
Okay, so first I want to say welcome to both of our speakers. I want to thank you for joining us for this colloquium. And to our members and guests, I'd like to introduce you to our 2 speakers. And as a reminder, if you have any questions as we go along, please use the Q&A button at the bottom of your screen, because I'll then see the questions and I will be posing them to our guests. First, we have Dr. Joellen Russel. She is an oceanographer, a climate scientist, and a distinguished professor at the University of Arizona. Professor Russel's research uses robot floats, supercomputers, and satellites to observe and predict the ocean's role in the climate and the carbon cycle of the past, the present, and the future. Dr. Russel was a research scientist at Princeton University and at the National Oceanic and Atmospheric Administration's Geophysical Fluid Dynamics Laboratory. Sorry, my tongue has trouble getting around all of that. She received her AB in Environmental Geoscience from Harvard and her PhD in Oceanography from Scripps Institute of Oceanography, UC San Diego. Joining her will be Dr. Emily Fischer, an atmospheric chemist and a professor of atmospheric science at Colorado State University. Her research focuses on air pollutants and their impact on climate change. Her most notable work was done in the Western Wildfire experiment for cloud chemistry. Dr. Fischer holds a BS in atmospheric science from the University of British Columbia, Vancouver, a master's degree in earth science from the University of New Hampshire, and a PhD in atmospheric science from the University of Washington in Seattle. Both women are members of Science Moms, a nonpartisan group of scientists working to demystify climate change, talk honestly about its effect on our families, and give other moms the info they need to help preserve this world, our world, for their kids. I would like to start, if both of you could turn your cameras on, by asking each of you to give our members a bit of your background, how you became interested in your particular field, what your main interests and concerns are now, and what are your hopes for the future. Take it away.
Emily, why don't you go first?
Of course. Hi, everybody. Sure, happy to. So my name is Emily. I am a faculty member at Colorado State University. I'm an atmospheric scientist. My work really crosses the air pollution climate divide and also crosses from air pollution into its impacts. So I work on a number of related issues. Probably most relevant to climate change and what we're feeling in the West now is the work that I'm doing on wildfires. So on that front, my team and in tandem with lots of other teams has worked on trying to understand the impact of environmental conditions on fire size and emissions. We've worked on where smoke travels from wildfire prone areas. We work on how the composition of the smoke changes as it evolves. We work on what happens when that smoke comes to an urban area. And that's where I pass data to epidemiologists and economists to try to figure out those impacts. So that's where my research sits. What I think is most interesting moving forward and what I'm, just starting to work on the fire front is to partner with communication teams. So how do we get air quality data into people's hands and help them make decisions to help protect their families? How do we help with that messaging and those logistics? I forget if I was supposed to tell you anything else, but that's probably good for now to get us started.
I love it. And I'm actually an oceanographer and climate modeler. So I use robot floats, supercomputers, and satellites to try and get a look at the future. It's partly that we've had robot floats out doing measurements for us when we can't be there with our ships. I'm a kind of Southern Ocean, the ocean around Antarctica obsessive. I have been since grad school, since even before grad school and college. And so for me, because I grew up in an fishing village on the Arctic Ocean called Kotzebue. And living there, I thought I knew exactly what blizzards felt like. I fully, have mushed a dog sled, know how to ride a snow machine, I'm very comfortable in an Arctic environment. And I wanted to see what it was like in the Southern Ocean, in the other westerlies, the Southern Hemisphere westerlies. So as soon as I could get down there, I went and was making carbon and oxygen measurements in the ocean by hand, because that's how one does it from a ship. However, it's inefficient. You realize when you're there and the water is like chug, 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 this 300-foot ship up the side of a wave and then shoots down the other side, dig the prow into the wave and watch the mountain of water just fall on the ship and press you down, and the ship's struggling to get back up to the surface. And you realize not only is this, dangerous, scary, and I still have nightmares about black water over my head, that I can't be everywhere and see all of the ocean. We don't have enough ships, not even close to enough hands to be able to do all the work to watch the ocean basically breathing, the gases going in and out, the carbon dioxide and the oxygen. And it's changing, and it's changing really quick. So in about 2004, folks from Scripps and Woods Hole and other places launched a global array of profiling robot floats called Argo. And these were just temperature and salinity and pressure, but they became the backbone of our observing system of what the ocean is doing when we can't see it from our ships. So anybody who was learning anything about the oceans in the 90s was essentially blind. They couldn't see where they weren't actually located, meaning, and even from satellite, you can't really see below the surface. So these profiling floats have become incredible. We're basically in the middle of a revolution in oceanography. So we would say, hey, it looks like when we came back to the same spot, 10 years ago, that it's gotten a lot warmer. And somebody would say, no, I'm sure the heat just moved. And we'd be like, well, it doesn't look like that, but I can't prove it. But now with robot floats, over 3,000 of them deployed all over the global ocean, and my floats, which are these biogeochemically censored floats, just means like, plant fertilizer, like nitrate, oxygen, pH, meaning how much carbon's been dissolved in the ocean, as well as chlorophyll and other sensors, micro sensors with really good batteries. So I use that and climate models, coupled ocean, atmosphere, land, ice, vegetation, craziness, 2 million lines of code to try to see the future, to try and see what's happening now and how it's going to change. And I can do that from Arizona in the middle of the desert, even though I don't have a port to hang out at. Robot floats and supercomputers and satellites can be used from right here. I have 2 kids, and I'm like all moms. There's just nothing I wouldn't do to see them prosper. And the grandkids I don't have because mine are still small. And I'm worried. I believe my model. I think we're right. I think we've made predictions over my own work from when I was a young grad student to now that turned out to be correct, really correct. And for me as an oceanographer, did you know that we can see the energy imbalance for the planet, how much comes in versus from the sun versus what's escaping? And that energy imbalance grows every year. And most of it, 93%, is in the ocean. It's warming. I see this everywhere. And the 1 out of 4 carbon molecules that comes out of anybody's tailpipe anywhere in the world goes into the ocean within a year. 1 out of 8 goes into the ocean around Antarctica, and I can see it with my floats. And so I am, I've been pressing for decades now, and I am pressing even harder now. I have to say, I'm deeply concerned, and locking arms with my friend Emily and Catherine Hayhoe and other moms to just try to get our fellow moms to lift their voices, feel comfortable with science that they didn't learn in school. Nobody taught this stuff back when we were going to school, but it's science and it's real and it's, it's validated and gorgeous and amazing. And we've made predictions and we've nailed them. And we need people to feel comfortable with that science so that they can raise their voices. I want them to call their senators. I want them to call the governor. I want them to call their mayor, the town council. I would like them to make a stink, because it's so important. Every single molecule of carbon dioxide that we burn and it hangs out in the atmosphere, it might stay there for as much as 800 to 1,000 years, making us warmer every minute it's there. It's really serious. So that's why I'm here. That's why Emily and I are friends, even from across states and all the rest of it, because we've got a problem and we're looking at different parts of the elephant here, but it is the same climate change elephant.
That's exactly right. That's how we're all together here is, all of the science moms work on different aspects of the Earth system, and all of us are either on, most of us are studying the impacts of climate change in some way or how it's propagating through the Earth system. And so I'm looking at it from a fire and an air quality perspective. But again, it's the same elephant. It's the exact same elephant causing problems. So where do we want to move next in our conversation? What should we talk about first? Should we talk about the impetus for science moms just a little bit, or?
Sure. And then Ben has asked, how do we evaluate the recent climate conference? And that was one of my sort of, but maybe we want to save that until we've said something about our science bombs.
Sure. So we hear you, Ben, and we will definitely get to that. We have opinions, or at least I have an opinion, and I'm sure
I do too. I absolutely do too. Let's hit it. Woo! Tell them about science moms. This one's fun.
Yeah, let's talk about science moms. So, why science moms? So, we're scientists, but we're self-critical, data-driven people in many ways. And so science moms started because 80%, more than 80% of moms across the US are worried about climate change. But some research showed that most moms are not comfortable talking about the issues. So they're like holding the worry, but not feeling confident in explaining the basics of the science and expressing their worry about it. And so that's why science moms exist, so that we can work to sort of distill information and provide accurate, concise, relevant climate information for moms. And the goal is really to help moms and families feel comfortable with the science and understand what they need to know about it and what they don't really need to know about it, and move that forward in terms of action. So when I think about climate change, I think about it, what worries me most is the timescale for action. And I think about that timescale for action on the same timescale as the intensive parenting period. So my kids are 6 and 9, and I think that by the time they go to college, we have to have really decreased our dependence on fossil fuels. So the next decade is very, very important. And so that's what motivates me to be a part of Science Moms. On a personal note, I study wildfires. So summer 2018, I had the NSF NCAR C-130 aircraft, and I was flying behind and into the smoke of many of the big fires that you've heard about in California, the Mendocino complex, the Carr fire, those big fires. So, I was in it. I was watching these big things, right? And 2018 was a very extreme fire year. Then in 2020, that was a really extreme fire year here in Colorado. My family ran from the Cameron Peak fire. And that smoke was over our head in Fort Collins for months. And so those rattled me, right? That, like Joellen said, I've been looking at the link between fires and climate. I've been looking at the impacts, right? And I was not surprised, right? But to live what your graphs tell you is a scary moment where you say, oh, I'm not surprised. That's very sad. I wish I was wrong, but I'm not wrong. Like there's a strong climate link to our fires that we're experiencing now. And extreme fires are horrible to deal with for society. So that, that really motivated me to, and continues to motivate me for this Science Moms work. Anything, what else? Yeah, you should add your perspective. That was a long answer, sorry.
No. It's that when your science and your life kind of come together, it is really, it's powerful. It moves you. God, I get up earlier. I stay up later. Seriously, it's the one where you answer your phone in the middle of vacation and your husband's kind of looking at you going, oh, geez, not again. And you're trying to make space for your kids right now because they're little and it's important. But at the same time, I need to launch this satellite to see the winds over the ocean at the same time that my floats are out. And we want to, NOAA said that we could take their P3 hurricane hunter. If we get funded, we can put the P3 hurricane hunter through the wintertime storms over the Southern Ocean around Antarctica to actually verify, because it looks like now that our winds worldwide have picked up, like over the ocean everywhere. There's like 2 blue dots and everything else is bright red. Our easterlies are stronger, our westerlies are stronger. And this is stirring the ocean. Like our ocean is stirring down. Every single major current on planet Earth has spun up. I know. It seems impossible. Like, well, if it moved, that heat or whatever, it's just woggling around all the currents all at once. Really? I mean, so as an oceanographer, I'm like, look, we're 93% of the heat budget. We're 25% of the excess carbon from fossil fuels. And we can see it. You want to know what the pH looks like in the ocean? It has a seasonal cycle, but if you watch it, it basically drops every 13 months. You can see it go down, 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 down with my floats. It's going down because as you add CO2 to the atmosphere, it dissolves in the ocean. 1 out of 4 molecules out of your tailpipe turns into carbonic acid and is titrating the ocean, making it hard for every calcifying organism, which are phytoplankton like coccoliths, coral reefs, pteropods that feed our salmon. Everything is feeling this. And did you know there was a paper out last year that's since been verified in multiple ways that every single species in the ocean that's capable of moving, like themselves, like fins, wiggles, anything, has moved deeper or moved poleward, all of them. I mean, it's coming so fast. I mean, my float's 13 months and I can see it isn't waiting. It's not like somewhere and not over there. The atmosphere, and Emily can tell you, is a dynamic atmosphere, but it's also only 3% of the increasing heat. The ocean's 93%. We see it all the time, everywhere. This isn't a joke or a debate. And everybody's like, well, why didn't you see it sooner? I'm like, well, because we didn't have robot floats till 2004. Now they're everywhere and we can see it. And it's a massive increase that everybody was like, huh, really? So it hits you right in the eye. And I grew up going to places like Glacier National Park to camp with my family. And it's going to be just national park. There won't be any ice. Here in Tucson, the no more snow, meaning it melts much earlier on we used to use them as rooftop reservoirs, sort of our mountaintop snowpack would melt late into the spring and into the summer. And that provided our riparian areas with water. But now it melts so much earlier that our streams run dry for a much, much longer part of the year. My mother's lilacs are blooming in northern Montana. They bloom 23 days earlier than they did when she bought the house. She puts her data into the NEON network. It's very cool, citizen science. So we see this everywhere. And of course, here in Tucson, more heat for me in the summer is cabin fever season. It's personal. I have to get the kids up early, like 5 in the morning, in order to be able to walk the dogs without burning their feet and make sure that the kids get some time to see the sky. Can you imagine ruining our kids' summers forever? I can't, there's a part of me that just can't bear it. It's too much. So what we need to do, and as scientists, we know this fully, we need to bend that curve. We need that carbon dioxide pollution curve. We need it to come down. We need to cut our emissions. We need to get good at cutting our emissions and then sell that to the rest of the world so they can cut their emissions. There's basically one answer. It's super simple. We need to not burn it. We need to keep it in the ground. We need to not burn it. We need to find other ways to get our energy needs so that we can make a more prosperous, happier, better future for our kids than we had, not worse. Sorry.
On that note, Dr. Russell, let's take Ben's question. How do you evaluate the recent climate conference? What do you guys think? What are the big takeaways from it?
Well, Emily, do you want to start? Yeah, you
Sure,
start.
I can. So, the first I want to caveat, Ben, that the last couple of weeks have been extremely busy in the semester. So I've, paid attention, but I'm also getting absolutely crushed. It's been an interesting experience to teach, post-pandemic. And, but anyway, just today in class, as a side note, today in class, we went over the CO2 water equilibrium. So very relevant to climate discussion. So, nations have not agreed to cut emissions enough to keep within our, 1.5 degrees Celsius by 2100 target. And so we haven't agreed to that. And the bottom line there is that it's probably not enough what's been negotiated at this point.
It's not enough.
It's not enough.
It's not enough.
Not enough. It's just not enough. And by not enough, I mean that without more work, we're losing coral reefs. Big storms are getting worse, like Ida. More extreme heat waves become common. Infrastructure will be challenged, does not keep up with extreme heat and flooding. It's not built to accommodate the kind of climate that we're setting ourselves up to experience. Ice melting leads to flooding coastal cities, and millions of people are at risk in the US alone. So where we are with those negotiations is just not enough from a scientific perspective. It's just not enough. So that for me is disappointing. At the same time, I'm happy to see some forward progress. So I'm happy to see us, moving forward. I'm happy to see the US and China committing to collaborate. These are all good things, but it's good, but not enough. And we're at a time right now where one of the things we like to say in Science Moms is later is too late. I think we're, when I looked at this, I said, later is too late. We cannot, you have to do more now. So that's how I'm feeling about it. And then, in class, I do this has been an interesting week as well. So I teach atmospheric chemistry in the fall for all our graduate students. So in our class, one of the things we have is air quality and justice in the news. And so one of the students also brought in last week a nice news article that was wasn't fully on the negotiations, but the timing of it was set to time with this, she just reminded me of all these things that I know, but it was really important, that women and children are more at risk for experiencing all these effects that I just talked about. Here in the US, Dr. Russell and I, we have a high locus of control. We can filter our air, we can turn the air conditioning on. We're not traveling to get our food normally, right? But women and children over the world, they are going to bear more of this than anyone else, more of the hardship associated with these choices and this sort of weak negotiation in my mind. And so that's how I feel about it right now. Do you want to add to that?
Oh, it's just one of those things where you get your history classes when you're in high school, and you learn that if all children aren't safe, then none of them are safe, right? In a world war, all the kids have to be made safe or none of them are safe. And under climate change, it's the same thing. You can't, you can adapt carefully, but they're not, their world is constrained, right, by that heat and the damage and the risk. It's a permanent debt we hand to our children and our great grandchildren. Now, the cool part is, and there is a cool part, that while the governments are all wrangling over what they're going to cut, and I don't want to say lying, not assessing correctly the amount that they are actually burning, they're double counting their forests, they're not counting wildfires, they're not counting what burns up in the coastal waters. And, you know, there's some accounting issues, which as a scientist, I'm like, oh, Adam, let's do this verification, like really carefully, really well, and then tell them exactly. None of this like wiggle, get out of it, but let's tell them, right? We found out too at COP26 that one of the biggest uncertainties is that the models and the observations in the ocean disagree by about 1 petagram of carbon in a year, which is about 10% of the total of all we burn in fossil fuels. So, and oh, by the way, you want to know where that is, that discrepancy? The Southern Ocean. It's right where I study. I know what's going on. It's so exciting and also awful. So the neat part is, and this is really cool, the United States has actually cut almost 20% off peak emissions. Our peak emissions were back in 2007. And everybody's like, oh, but we've got partisan gridlock. We can't do anything. I'm like, well, under all that gridlock, we dropped 20% off our emissions since 2007. And it was individuals and businesses making wise decisions for their grandbabies. Full stop. Investing in the future, things that needed doing, that saved them a buck, right? Conservation always saves you money. It's all those solar panels and all those, here in Arizona, we have a nuclear power plant that provides 42% of our energy at Palo Verde. You know, everybody's like, but what do you do to cool it? Like, it drinks toilet water from Phoenix. That's it. They've been trying to get permits to do another one, and they're really struggling here in Arizona to do that. But there are so many options, so many people. And in my state, they thought big early, you know, Lake Mead, Lake Powell, you know, our nuclear plant's paid for. It's 50 years old and it's all paid for now. There are options that we could choose that would get us to zero emissions power, electricity quickly. I mean, and new electric car companies opening all the time. And it's an exciting time. We could bend that curve. We could drop our emissions even more. We are doing it. We're dropping faster than almost any place on earth. And nobody even noticed. And just by the way, it is the law of the land. Under the 2007 ruling from the Supreme Court, carbon dioxide is required to be, it was Massachusetts versus EPA. Carbon dioxide is required to be regulated as a pollutant under the Clean Air Act. And the Supreme Court already ruled on this. So it's only a matter of regulation and folks making wise choices and maybe a little hustle on transitioning quickly.
I'd like to join a couple of the questions that I'm seeing coming up. And one of them is that science is, to all of us, abundantly clear that there's a problem. Solutions may not be as clear. What kinds of solutions can science bring to the table? Do you think we ever will be able to transition to nuclear energy? I'll leave that as our first question for you guys to attack. What options are there that science could bring to the table?
Sure. So the way this will work, right, could work, is a large collaboration, right, between the earth scientists, the engineers, and the social scientists and the policymakers. So our job is to say, this is what we understand about the links between things, and this is what we expect moving forward. And then we constantly adjust that based on new information. And any surprises that happen or because of blind spots due to observing in models. So that's what we do. At the same time, right, the engineering communities at universities are working very hard on renewable energy. Like and when there are people who sit at the intersection of earth science and engineering, some of them are in California, and have done very elegant models of what it would take to how much land you would need, how much, what materials you would need to transition the US fully away from fossil fuels, for example. And what I could say from that is that that is very possible. That's just, it's a lot of work.
Will.
You have to focus on doing it. You have to decide to do it as a society.
Yep.
And you have to do it equitably and justly so that equity is at the center of that transition. But it's perfectly possible if we decide to do it. So
We're down 20% and nobody noticed.
Yeah.
Knocking this one out of the park is honestly, sorry, go ahead, Emily, but you could imagine, not as scientists, but just as human beings and citizens, I would love to see our federal government set up a $500 billion zero carbon energy bank, where basically you could get a loan for any project that would have zero carbon energy over a certain threshold. But the trick would be is if you got it implemented within 5 years, clock is ticking, people, that you would actually get those loans forgiven, right? Don't implement it, you have to pay it all back. Implement it, get it going, we forgive your loans because we're grateful to have a new source of zero carbon power. The idea of activating our entrepreneurs and our innovators and just the muscle behind our states and our energy grid and energy folk, I have huge confidence in the possibility. Which one of our states wouldn't give its left arm to have a bunch of free to them power plants that have zero emissions and no nasty smog? I mean, really, who wouldn't get their butts in gear and get that permit and that plan in place if they knew if they could just get that puppy up 5 years later, boom, they've got free power for the people. I mean, now what company doesn't want to come and site in a city or a nation that's already gone to cleaner skies, better breathing, and all this innovation ecosystem? Everybody's having a hard time. They're saying, oh, it's going to cost money and drag their feet. And yet I swear I can just see it. We dropped 20%. Nobody even noticed. We grew our economy at the same time. We grew our population. We looked after our kids and our pets and our security and all those important things, and dropped 20% of our emissions and nobody noticed. I swear we could do this with just a little elbow grease and will, just sort of why we're doing Science Moms. We just need people to raise their voices. We have regular folks doing wise and important things all across the country, cutting emissions. And we've got politicians and folk who just don't think it's that important.
I'm going to go to a few technical questions that we've gotten, or slightly technical questions that I've received. One of them is, we healed the hole in the ozone layer in our times. I know that Dr. Fischer, you have studied the self-cleaning abilities of the atmosphere. Is there any way for us in the future to clean the atmosphere of some of this carbon?
So, I don't want to get so technical here, but the ozone hole is a bit of a different problem. But at the same time, it is probably the most beautiful example of international environmental legislation in action. The ozone hole will heal over the next 60 years, at least if we don't do anything silly. And the Montreal Protocol and the subsequent amendments to that actually have been some of the most effective for climate change as well, because they've also inadvertently in some ways regulated greenhouse gases. That being said, when you think about climate and you think about healing, it's probably most helpful to think about each of the greenhouse gases separately. So methane, right? There's a lot of talk about methane, and there was quite a bit of talk about methane in the recent negotiations. Methane only has an atmospheric lifetime of around a decade. So if we cut methane emissions, then yes, methane abundances in the atmosphere will absolutely go down, and they will go down on a relatively rapid time scale, because that lifetime, the loss process for methane in the atmosphere is only really reaction with the hydroxyl radical. And we know that rate, and we know an approximate abundance of OH in the atmosphere, and that'll go down. If we cut methane and we simultaneously cut nitrogen oxide emissions, ozone in the atmosphere, tropospheric ozone, should also come down relatively quickly. If we can clean up some of our aerosol emissions, some of the black carbon, sort of the particles that are dark, that absorb and actually heat the atmosphere. Those have very short lifetimes in the atmosphere. I'm not talking years anymore. Now I'm talking months, weeks to months. Yes, that would also, the atmosphere should respond relatively quickly to that. CO2, and I'm going to let Dr. Russell jump in here now. CO2 is more complicated because of the oceans. And to put it sort of bluntly, so for CO2, right, the sort of, I'll give you the big picture and then I'll pass the ball, is we're very good at knowing our CO2 emissions, I would say. And in fact, relative to some of the other things, our anthropogenic CO2 emissions, some of it's going into the terrestrial biosphere, some of it's going into the oceans, but there's very long timescales for ocean exchange from the surface down to the deep ocean. And so that timescale is a bit different than some of the other greenhouse gases. So do you want to take it from there? That might be going into the ocean world.
So the ocean takes about 1 in 4, and the terrestrial biosphere is greening and taking up about 1 in 4. And a big chunk of that's actually happening in our Northeast, where our forests, we've stopped farming and have allowed our suburbs to afforest way more trees. But in general, only about half of the anthropogenic emissions go anywhere. The other half, 1 out of every 2 molecules of carbon that come out of your tailpipe, just hang out in the atmosphere, right?
Stay for a long time and builds up.
Right. So even if we decrease our emissions, right, which we've been doing, right, we're still emitting 80% of what our original was. And that is, half of that is just hanging out in the atmosphere. If we got all the way down to 0 emissions, 0, like no burning, period. No burning. I'm going to make it my tagline of my email, just don't burn it. And everybody's going to say, well, why can't we remove it through geoengineering or some kind of, because it's expensive. All of that. The cheapest, guaranteed to work, only thing that's proven to work is to not put it in the atmosphere in the first place. Literally the only thing that's guaranteed to work that costs the least is don't burn it. Everything else, once you've blown it into gas, it's incredibly expensive energy-wise to remove it from the atmosphere. And it hangs out there. 1 out of every 2 molecules you burn hangs out in the atmosphere and doesn't go anywhere until we hit net 0. I know. Now, doesn't that blow your brain? So even when we get it all down, all the countries of the world, all of us down to 0, 1 out of 2 will still be hanging out in the atmosphere. At that point, once we get down to 0, then we can talk about whether or not the natural sinks will actually continue to take up carbon. Now, it's likely that the ocean will continue. But it's likely that the ocean will continue to take up carbon because so much of the ocean mixes on timescales. That means that there's a bunch of ocean that has not seen our human atmosphere. It's also likely that there are lots of plants that don't have to lose as much water when they open their stomata in order to capture more CO2. They can keep it nice and tight. Here in the desert, we're all about this, right? So they green because they don't have to lose water when they capture CO2 as much. So but all of our predictions, like when we put plants in closets and heat them up, is that drought stress and heat stress weakens that effect on land. And then in the ocean, there's this really bad complication, which I'm really sorry to tell you all, because I bet you don't know this, But the ocean, the atmosphere has what, 600 petagrams of carbon in it? Is that about right, Dr. Fisher?
Mhm.
I think it's about 600, and we're worried we're going to go up to about 900. Did you know that the ocean has 24,000 petagrams of carbon in it? Loose, dissolved, just washing around in there. It's mostly in our deep North Pacific and our deep Northern Indian Oceans, but over timescales that are shorter than we would like, maybe, 100 years to 200 years. And some of that right now is actually accessible in the Southern Ocean, because remember, our winds have cranked up and are stirring the ocean harder. This is something that terrifies me. We cannot stir the ocean, because what you might stir up might actually burp back out. So, and a lot of our models did not predict the stirring extra. So there's a lot of great science that needs to be done, but the fact is we have to cut it, because it will keep hanging out there, making us hot every second until we cut the emissions, right? There's really, and the whole, everyone, I'm terribly afraid. Like, there's all these ocean solutions people keep talking about, like growing seaweed or kelp or burying things in the ocean. And like I said, the ocean's already threatening to burp stuff out. So for me, I'm like, putting things in the ocean when it can just get mixed right back up to the surface seems reckless, dangerous. It might end up being we spend a bunch of carbon gathering up carbon and sticking it into the ocean, and then it comes right back out, right? So we burn all that energy, got nothing out of it, and it came back out and made us hot. So I'm a little worried about greenwashing, people who make a living off selling us technologies to clean our atmosphere that won't work. And the cheapest, best thing we could do is just don't burn it in the first place.
Yeah.
That leads me to one of the questions, which is, could you explain how, sorry.
Happens on every call.
Yeah, it's my son, of course. I don't know how to stop it, so I'm going to mute myself for a moment.
And I'm going to take one of the questions that I see to help. How does that go?
Go.
So let's talk about this, what's happening to the atmosphere because of increased fires in the West. So let's talk about that question that I see. Yeah, it's the same question in both spaces. So the main point, so let's just, I want to just take a step back, and then I'll talk about the impact of fires on the atmosphere. So, but the first, the greater direction is the impact probably of the atmosphere on fires in the West, right? So the entire the Western US has been increasing in aridity, in dryness, what we call vapor pressure deficit, over the last several decades. We know now that much of that increase in aridity, which aridity really is the foundation of fire weather. That increase in aridity, approximately 2/3 of it is driven by anthropogenic climate change. So climate change is making the conditions for fires more likely in the Western US. If you look at the grass behind me, right? And this is where behind my office in Fort Collins. If that grass is dry and I toss a match, it's very different than if that grass is wet and I toss a match. So the link between climate and fires is really towards climate increasing fire frequency, intensity, and size, and duration of the fire season in the West. Smoke, so when something burns, right? Smoke is a very complex mixture. What are the big players? Carbon monoxide, carbon dioxide, fine particulate matter. In smaller abundance, but are very important for human health, right? Are lots of other different hydrocarbons, things like benzene is in there. A lot of different products of incomplete combustion show up in that smoke. That smoke, when it's really, really thick, can have all kinds of different impacts. So smoke can impact clouds. So we're just beginning to understand this. What smoke does in general is make the size of the cloud droplets very, very small. So there'll be more of them and they'll be very, very small. And it's likely that that decreases the chance of precipitation. So that's a feedback that we're just beginning to think about. When that smoke is overhead, it changes the light, right? So that smoke can change the vertical structure of the atmosphere, sort of the temperature profile of the atmosphere, make it more stable. That smoke can change the light reaching the surface. That can impact for example, the radiation hitting the surface that's available for plants. When that smoke, that smoke can also impact how, the air quality below it is processed, because all of the chemistry in the atmosphere is largely driven by light. So anytime you change the light, you change the chemistry of the atmosphere. So those are things that the smoke does. The smoke also transports nutrients. So in our high altitude ecosystems in the West, when a smoke plume intercepts, say, Rocky Mountain National Park near where I live, which is behind me over in this direction, to the left on the picture you're seeing here behind me, there's our sort of, bursts of nitrogen that are transported in that smoke. So those are things that the smoke sort of does to the atmosphere. But in many ways, the atmosphere is doing a lot to drive the fires, to create the environmental conditions that make fires favorable, on top of, right, a sort of a legacy of land management choices in the Western US. So hopefully that helps with that question.
I apologize for my previous interruption. I have two ocean questions. One is, can you explain the role of global warming on the action of the Gulf Stream? And I know that's Northern Ocean, not Southern Ocean, Dr. Russel.
Oh, no.
But how
Well,
changes in the Gulf Stream may affect the future climate of both the global north. And then the second ocean question is about fish farming. And how is fish farming affecting the oceans?
well, fish farming, once upon a time, because I grew up in a fishing village, I was like, oh, that sounds like not fun. And then I found out that we were overfishing 30% or more of our global fish stocks. Most of our major, delicious, larger fish were being fished out. We kept fishing the big ones, and then there weren't any to do the great big spawning that is required in order to replace them. And climate and warming waters are also affecting that as well. So I am a huge fan of fish farming now. If I had my choice, we would have big wind farms offshore plus fish farms, so we could visit and maintain them both all at the same time. I use ocean robots all the time. I don't see why we couldn't have maintenance bots. But done carefully, done wisely, with good regulation, it's a great way to provide wonderful, wonderful, careful, clean, good protein. And also, because the ocean actually can support it, but it really needs to be regulated quite carefully and made sure to be put in the right places, so that we're not doing any damage to our natural ecosystems. But the current damage to kind of the wild fisheries is so extensive in so many places. And the places where we have got good regulation, they're bouncing back. So we do have recovery in many places, but it requires things like marine protected areas, which are basically protecting the nurseries of the ocean, our kelp forests, our mangroves, coastal areas that have high diversity and high variegation in the cover allows for the larval phases, the ones that are defenseless and are just snacks for everybody else. They need a place to hide until they're big enough to be able to make their own way. And so marine protected areas are a super part of this. But in conjunction with that, there's no reason that we shouldn't be getting way more of our fish. I'm not against sport fishing or basically fish tourism. I think that's a great thing, and it doesn't put a whole lot of pressure, and individual fishing lines, et cetera, are actually very unlikely to cause permanent, terrible damage, unlike some of the nets and the dredging and the long line things that we do in other ways, the factory fishing. So I'm pro aquaculture. Edinburgh, the University of Edinburgh has one of the most famous aquaculture programs in the world. And I've sent 2 of my undergrads there to get their masters, because I would love it if the US found a more sustainable way to provide our fish protein. And it's delicious. So I'm pro fish farming, as long as it's done very carefully and well. And there are many places in the world that do it very carefully and well. I'd love it if it were us too, so we weren't eating what Sylvia Earle likes to call bushmeat. So, fishing the wild animals it's not good. It really isn't. It reduces our biodiversity. It reduces the sustainability of these populations. And in the face of heavy climate and human impacts from noise, big ships, use of coastal regions, resorts, et cetera, I would love to take the foot off the gas when it comes to fishing. I also saw, are the reefs salvageable? Well, we've already just killed 14% of all our reefs worldwide. 14% are gone now and are covered with algae. More is probably coming, but if we could bring those emissions down sharply, reefs do spawn and they do adapt, but they need more time. They need more time. And so we need to slow down the climate train and long enough to give them enough time to adapt carefully. And there are other supports we can do, et cetera, but generally we just need to make it not heat so quickly, not so many marine heat waves, because they're just being battered by bleaching due to heat waves. And there was another ocean question, more complicated. Which one was it? Remind me.
Sorry, I had to unmute. On the Gulf Stream.
Okay, lots of people like to look at the North Atlantic as a big driver in climate and the Gulf Stream delivering water to the North Atlantic. But I don't know if anybody saw the New York Times front page article on the Gulf Stream is slowing down. That's not true. And if you read all the way down to the bottom of the article, my adored friend and colleague, Susan Lozier, Professor Lozier she's now the dean at Duke, of their College of Environmental Science. She said, no one actually thinks this is happening. The measurements don't support it, but other old dudes up high in the article had already said that it really was. And she's the one who put the array in from Greenland to Iceland, Iceland to Norway, Iceland to Scotland, which is called OSNAP, and actually monitored how much of this change was happening. Actually, the Gulf Stream's speeding up. It's not slowing down, and the overturning associated with it in the North Atlantic is not happening either. And if you read down to the bottom of the article, you will see this. And there's a reason. It's that the winds have picked up, and the winds are what drive the Gulf Stream. Now, it's still warmer. It is absolutely still warmer, and especially just for folks who worry about if you have relatives who live in the Gulf of Mexico or in Florida, that loop current is much hotter, and the isotherm around it of the very warm water that fuels hurricanes is much closer to shore than it was 30 years ago. So it's a big challenge, but it's not slower.
Okay, now a question, how accurate, and this is from a member of the Plato SDG on climate, how accurate and reliable are deep ice cores at defining the historical air temperatures of the Earth? Do you guys have any?
I don't work on anything related to paleoclimate, so I can't answer that one.
I do that a little bit. I don't do ice core measurements, but I do a little paleo work. And I'll just say that they don't actually measure the temperature directly. They measure the Del O18, the Delta 18 isotope of oxygen in the ice core. That's how, and they do directly measurement in the tiny bubbles that are captured in the ice core. They measure the actual concentration of gases because it's basically trapped air, but they don't get the temperature from that directly. Once it's made into ice, they look at because the Del 18 is actually affected by how much ice is on land. What you're looking at is not really temperature, you're looking at ice volume. Like how much is Antarctica and Greenland and the Laurentide ice sheet during the last glacial max. That's kind of how they do it. So in terms of, I'm sure my ice core colleagues could give you a better idea of exactly how accurate a geochemical proxy for temperature is, because it's not really temperature, it's ice volume. But the gas quantities are excellent. They're really quite extraordinarily good at telling us how much CO2 is in the atmosphere. It's fascinating, frankly. They also do methane out of those same cores from swamp and peat and other terrestrial sources of methane. It's amazing.
Okay, I'm now going to ask a question from a retired science teacher. How can we continue to wake up the unbelieving segment of the population to what is really going on? I come originally from South Louisiana. It's a big oil and gas state. And there are some people there who just don't buy it, that there is anything like climate change. What do you recommend that an individual person could do, talking to friends, neighbors, skeptical family, etc.?
So I don't spend a lot of my time on people who are anti-science, right? I just don't spend a lot of time. That's the honest truth. At the same time, I give people the benefit of the doubt, right? And I think there's ways to bring up climate change that are really natural in family settings. Living in Colorado, I'll give you an example. It was very hot here this summer for a very long time. That's a great time to bring up climate change. When people say, yes, I don't remember it ever being this hot, then you say, yes, that you are experiencing climate change. When people say, I don't remember the fires being this bad, gosh, this seems so bad. I say, yes, this is climate change. So I think that another thing that's very important with climate change sometimes is to shift away from this is an I problem to this is an us problem, right? This is a society level problem that will require societal level shifts, and those need to be done equitably and carefully and caring for people who's might have to change their livelihood slightly to deal with this. But that doesn't necessarily mean that climate change is not real, right? Like you can accept that climate change is real and accept that that will have some consequences for you and you may have to change. You don't have, those are not mutually exclusive, right? Like you can understand that this is a way that we produce energy now. Because of climate change, we're going to have to make a choice to produce energy a different way. And now we move forward. So
Yes.
In general, I think, public education is very important. People need to understand how to find reliable sources of information, how to have some, basic scientific literacy. The fundamentals of climate change are not that hard. I could explain to you right now how I explain to, the general public how climate change works. And on Science Moms, we have a lovely set of videos that walk through greenhouse gases. It's called The Line or something like that, right? And it's this lovely video that it talks about greenhouse gases. They build up in the atmosphere. That's a blanket. It traps heat, and away we go. So I think, simple communication is best. I don't tend to engage when there's, when people just don't want to, agree on the basics, right? One thing that I use sometimes that I've used in the past, people say, oh, I don't believe this is happening. And I'm like, do you believe thermometers work? Like we're measuring the temperature and it's going up and we can predict this with basic physics. So, some of these things are important. I also think the messenger matters, right? So if someone trusts you in other aspects of their lives, right, and they know that you genuinely care about them, then you might be a good messenger for that person, right? And you can say, well, this is how I understand it. So those are just some general thoughts on that. But most people in the United States right now understand some basics of climate, agree that this is happening, and would like to stop the problem. So it's a minority of people, actually.
It always appears to me to be more of a mismatch between our politicians and our regular folk. I say that because I live in a big red state, right? Maybe we're going a little purple lately, but I live in a big red state. I teach in a big red state. I do my research in a big red state. And my folks and my family live in places like Montana and Alaska. So I've got fair few cousins and uncles and other folk who are firmly of the opinion that until I show them. Now, most of them are engineers. It just happens to run in our family. And so when I show them the microsensors and the floats and all the rest of it, that gets to them, right? So there are ways as an individual I can affect my own folk. But what worries me more is basically this disconnect between our politicians and who are listening to the people who donate to them, right? And are not necessarily, our priorities might be as regular people, might be the economy, might be safety for our kids, and might not be climate, but somebody whose business depends on burning fossil fuels, they might be lobbying very specifically on that one issue, right? So the person who really passionately cares about something and is willing to donate on its behalf is going to get more attention from our politicians just kind of normally. But I don't actually think that I don't think everybody says, oh, there's all this flack. I'm like, really? Because the American Association of Petroleum Geologists made me their distinguished lecturer in 2011 and sent me to the oil patch from Saskatoon, Saskatchewan to Chevron headquarters to Houston and ExxonMobil to the Montana Club in Billings. I gave talks to the AAPG all the way to St. John's Bay to the oil patch on oceans and climate and global warming. I was their first person to actually come talk to them about global warming. Guess how many times I got heckled? Zero. They had great questions. They're geoscientists for the most part, and geologists who deeply respect what they can see with their own eyes, with what their boots and their measurements can tell them. And they might argue about points, but I didn't get heckled. It was actually fun. So my experience here in our big red state and in our, with the AAPG is that, yeah, it's not regular folks. We dropped 20% in our emissions and nobody noticed. We did that while nobody was paying any attention. We just made wise decisions, individuals and companies and towns and states, one by one, pushing the ball uphill. I'm proud of us because this isn't happening everywhere else in the world. It's happening here. So I know everybody hears us. It's just a question of, can we get through the noise, which is kind of why I love Science Moms so much, because what we do is we're only talking about climate and we're just trying to say, raise the profile of climate action, raise it, get individual regular folk to raise the profile with all of their elected officials. I don't care, because look, in your town, you are doing adaptation. In your state, you're working on your grid and your energy sources. And at the national level, we are figuring out whether or not we want an energy bank for zero carbon power. Every single one of these levels, we need to make it a priority, right? Instead of just letting the people who want to sell us fossil fuels have a clear field, because no individual makes that their top priority, right? Most of us say, oh, well, we're worried more about the economy, or we're worried about, having enough hospitals or COVID. I mean, it starts to tick down, at which point I think they don't hear us. So that's why I think people like Dr. Fischer and I and all of the other science moms are ready to kind of lay down in the road and say, we need to push it up our priority list. We need every single senator to get, their calls. If half the calls they get are about what are you doing to reduce carbon pollution, they'll start listening. But until we actually get it to be half of the calls they get, they're going to find other reasons, usually, dollar type reasons, to not make it their main priority. And right now, they've been considering in the infrastructure package, they're now considering in the regular budget process about whether or not to fund more climate research and or adaptation. And I have hope. I do. I think we just need to get on the phone, make some noise.
I would
That's
say
just me, though.
one personal note, I can give a little anecdote of how that communication has worked for me. I was on a plane coming back from El Paso. So a few years ago, we worked on the air quality in Carlsbad Caverns National Park, which is very close to the Permian Basin. So I get on the plane, I got my headset on, I got my laptop open because I'm like right looking at the calibrations I just ran in the park. And the guy sitting next to me, he looks at my laptop, my business cards taped to the top of my laptop. So I know which one's mine. He's like, hey, what are you doing? And I was like, oh gosh, chatty. So I like take the earbuds out and I'm like, oh, I'm Emily. I'm just going back to Denver. And he's like, what were you doing in Texas? And I was like, I was working on air quality in this park. And I was like, what do you do? And he's like, oh, I'm an oilman. I like work in the oil fields. I was like, oh, okay, cool. And he's like, what are you measuring? And I was like, methane, lots of it. And he said, oh, is that leaking out of the stuff we're doing? I said, absolutely it is. And absolutely we can detect it. Right. It was a very collegial discussion about, I was like, yes, you're leaking lots of things and it's probably contributing to ozone problems in the park. Oh, yes. Okay. Like it was a very science-based, and I was like, you should probably stop doing that. I was like, you should be a little bit more careful. So, but we were of the same age and, we talked about it. And so where people are, thoughtful, kind, and considerate of each other, I haven't had really any problems with communication.
Yep.
What else should we answer here that would be helpful? Where do you want to go next?
I think we've hit on most. I'm scrolling through the questions. I think we've hit on most of everything, unless somebody wants to add something new to the Q&A. Oh, here's one. How big is your organization? Is it mostly academics or women working in business? And I will add to it, I did not see a button where one can donate to your organization. Do you accept donations?
It's not about donating, it's about doing.
Yeah,
So,
actually, it's do we say? I mean, I think there were amazing female donor who made this possible originally through Potential Energy, and post-divorce decided to help with this communications campaign. So we don't really take donations, we just take help.
Yeah. And this is many of the there's now 12 of us, and there will be more of us, and our job is to be able to be responsive to requests like this, so to be able to come and let people ask questions of scientists and have more dialogue on this issue. But what we need is not donations right now. What we really need is phone calls. So we need everyone to talk about climate change, to feel very urgent, that feel this sense of urgency, because the changes that we need to make are at a society level, and we really have about a decade to make real big investments in infrastructure changes so that we are no longer burning fossil fuels pretty much in 15 to 20 years.
I want to make it a horse race. I'm desperate because I do carbon verification for the ocean. I'm only responsible for 72% of the Earth's surface. And when I started, we had 0 biogeochemical floats. Now we have a global array funded through the National Science Foundation. We're deploying like crazy people, right? We can do this, right? But we need to raise awareness, and we need people to talk about it. We need people on Twitter. We need people across the back fence at the Plato Society. We need people to pick up the phone. We need you to call the town council, the mayor, the governor, your senators, the president, and everybody on down. Quite literally, like I have an alert in my phone once a week on Saturday morning when I'm doing my chores. I literally put my earbuds in and I have a series of phone numbers, and all I do is leave a message and say, this is Joellen Russel. I'm one of your constituents, and I want to know what you are doing to cut carbon pollution, because I'm very worried about climate change and the impact it will have on my children. And I know it doesn't sound like a lot, but I am desperate to make my senators half their calls every week. It's going to be climate, half every week.
Yeah.
Until they fix it.
Yeah. And I would say that part of Science Moms is you don't have to feel the responsibility that you are going to propose every solution here. Society has to decide this is a priority. And then all the engineers and the social, every part of our society will work towards zero carbon emissions. That's so that you're like, my role will still be an atmospheric chemist. I will go out, I will measure methane, I will still work on how smoke travels through the atmosphere, how to prepare society, how smoke is impacting air quality, what regions are most susceptible. I will still do my job. That will be my job. And, you know, the people whose job it is to fix the grid, that will be their job, right? So I want, part of Science Moms is to get us to not be so overwhelmed and to say, this is a we problem and this is a top priority for my family. And I want solutions on every front. And I will, but you don't have to bring the solution. You don't have to be.
I don't tell them what to
engineer.
do. I call and I just say, what are you doing to cut carbon pollution? I just want my senator to get off their butts. I want my people to be, all of them. And the fun part is we have a lot of moms who do it now, and it costs me literally nothing. I'm vacuuming, I'm in the backyard, like picking up the dog, whatever, I'm like doing the laundry, and I'm like going through my call list, and it's not that many actually. And I know I'm a pain in the rump, but I'm okay with that because I need all of my politicians, everybody who represents me. I want them to be working on it. And luckily I live in a place where lots of us are doing it. And I'm hopeful that all of my folk will be working on it. I know my city council is, I know my mayor is, I am losing with my state legislature and with my governor, but winning with my senators. And I just want to say, it's so nice that you invited us to come and talk to you. I have just this deep sense of community in our country, in our nation, and in the world too, but in our states and our people. I talk about this all the time. And I do it on Good Morning Arizona. I sometimes do the climate commentary with our weather people. And I never get meanness. They might say that's not as important to me, but I never get meanness. And most of the time I get help. And so we're just hoping that one by one, by 10, by 100, by thousands, over and over and over, that we raise this and we put all of our muscle together. It's like a Rosie the Riveter moment, right? And we need everybody to decide that this is not too big for us. This is just our size. We can do this. And no, I don't have a specific silver bullet. I just know that we'll figure it out and get it done. We just have to decide now that this is where we're going.
I have an additional question. Are you okay if this has been recorded, if our members show this recording to their friends and relatives to encourage them? And are you okay, and I'm sure you must be, if I send out a link to Science Moms to all of our members? I have to ask permission of our president. Send it out to all of our members.
I'm sorry, Emily, what were you going to say?
Yes. But you know what will be more effective, right? So here we're speaking off the cuff, right? But we've spent a lot of time on the information on Science Moms, making sure that it's short, it's digestible, it's funny. So we're very happy to have you send everything out on Science Moms and this recording. Honestly, I feel like the Science Moms resources are more impactful than we've been today, right? Because here, we are actually interacting with you, but if you weren't here in this Zoom space, that might be like not as fun, right? But those on the website are lots of 1-minute videos, 30 seconds videos. I have one explaining the connection between fires and climate to another mom. That's a great one to send out for anybody who's thinking, oh, fires and climate, what's the link there? Joellen, I think yours is on extreme heat. If I remember right, Melissa Burt, who's another Science Mom, did one on drought, right? So we're trying to create these very digestible things that can be shared because, not everybody has a Play-Doh society, right? But those things, those videos and things, those can be shared. And everything that we have there has been reviewed by us. And is good information.
Okay, well, I guess I have to turn my video on, I've been told. Thank you very, very much. I'll take off my down jacket because it's chilly here in Venice, California. Thank you very much for sharing your information with us today. And I will send a link if our Plato Society president approves to everybody. And thank you very much.
Thanks. And I put it in the chat for everybody so that everybody here can just click on that resource link. That's what I'm talking about. So,
Okay.
So that they, you can have that. There's a series of videos, books, TED Talks, things like that. So thanks, everybody.
Thank you. Thank you to both of you. And to all of our members, if you do go to the Science Mom website, which I have done, it's really fascinating what they have. As a reminder, our next colloquium will be with George Gascon on a totally different topic. It will be on rethinking the criminal justice system. We're not doing a colloquium in December. That one will be in January, and you'll get information before January about it. Thank you very, very much to everyone who joined us, and we'll see you all in January.